In this video, I want to walk through writing equations of parallel lines. So we're going to do 5 examples, and in each example you're going to be given the equation of a line, and they will be in varying forms. The first one will be in slope-intercept form. You'll also see them in standard form, point-slope form, and horizontal and vertical lines as well. And in each example, along with that line, you'll be given a point. So our job is to write the equation of a line that's parallel to this first line, but passes through the given point. Okay, so remember, parallel lines have these certain characteristics. They have the same slope, but they have different y-intercepts. And what we care about more than anything is the notion that they have the same slopes. So what we'll need to grab from this original equation in each case is just the slope. And once we know the slope, we can use it and write our new equation. Okay, so in this first example, we want to write the equation of a line that's parallel to y equals 2x minus 7, but passes through this point P, negative 3, 5. So if this is written in slope-intercept form, I know that the slope is 2. So I can say m equals 2 because parallel lines have the same slope. Okay? Well, let's go ahead and write our new line, and we'll write it in point-slope form first, and then we'll write it in slope-intercept form, and I'll show you something we can do with those two. So, point-slope form is y minus the y-coordinate equals m times the quantity x minus the x-coordinate. And we have our slope of 2, and that came from our original equation. And since we want to write the equation that's parallel, we'll use the same slope. And from our point, we'll use the x-coordinate negative 3 and the y-coordinate 5. And we'll just plug everything into this equation. So y minus the y value, that's 5, equals m, which is our slope, that's 2, x minus the x-coordinate, and that's negative 3. Since I'm subtracting a negative, I'll go swoosh swoosh and make that an addition problem. And I'll go ahead and say y minus 5 equals 2 times the quantity x plus 3. And this is the equation of the new line. It's parallel to y equals 2x minus 7, but it passes through this point P. Okay, let's go ahead and do it again, but this time let's write it in slope-intercept form. So we have y equals mx plus b. And again, our slope is going to be 2, and our ordered pair here will give us an x and a y value. So our y was 5, our m is 2, our x is negative 3. So it looks like we're solving for that y-intercept, so we can write it in slope-intercept form. So 5 equals negative 6 plus b. So when I add 6 to both sides, it looks like my value of b is going to be 11. So finishing this up, I'll say y equals 2x plus 11. And this is the equation written in slope-intercept form of the same line. It's going to be parallel to this original line, but passing through the point P, negative 3, 5. So one interesting thing that you can do to make sure that you've kind of done both of these correctly is you can easily take a line that's written in point-slope form and convert it to slope-intercept form simply by distributing and then adding this 5 over here in this case. So we'll have y minus 5 equals 2x plus 6, and when we move the 5 over, we'll say plus 5. So y equals 2x plus 11, and there you see it's the same thing. But I'll go ahead and work both ways in all these examples, just so you can choose whichever one you're most comfortable with doing. So after each example, I'll show you the graph of what these look like. So go ahead and take a look at this first graph. In this second example, we're going to write the equation of a line that's parallel to this line that's given in standard form, 2x plus 3y equals 6, but it's going to pass through this point Q, 9, negative 7. So once again, to be parallel means that it has the same slope, but this line is given in standard form, so I'm not sure what the slope is just by looking at it because it's not in slope-intercept or point-slope form. So I'll have to start by solving for y. So let's go ahead and subtract 2x from both sides, and I'll get 3y equals negative 2x plus 6. When I finish dividing everything by 3 to get that y all by itself, I'll have y equals negative 2/3 x plus 2. And what I care about here is the slope, this negative 2/3, because now we've written it in y equals mx plus b, so here's the slope. So I'm going to go ahead and jot that down up here. M equals negative 2/3. So here's my slope, and here's the point that I know the line passes through. So let's go ahead and write its equation. We'll start by writing it in point-slope form. So y minus the y-coordinate equals m times x minus the x-coordinate. So it'll be y minus, and we have negative 7 for the y-coordinate, equals the slope, which is negative 2/3, times x minus the x-coordinate. And here I have the subtraction of a negative, so I'm going to swoosh swoosh and make that a positive 7 equals negative 2/3 times the quantity x minus 9. Okay, so here is the first equation that I want to write, and this is the equation of the line that's parallel to 2x plus 3y equals 6, but it passes through this point Q, 9, negative 7. I also want to go ahead and write this equation in slope-intercept form. So we'll start with our y equals mx plus b, and we know that our x-coordinate is 9, our y-coordinate is negative 7, and our slope is negative 2/3. So I'll be solving for b, which is my y-intercept. So y is negative 7, the slope is negative 2/3, x is 9, I'll go ahead and put 9 over 1. So I have some simplification I can do here. So negative 7 equals negative 6 plus b. So when I add 6 to both sides, it looks like my value of b will be negative 1. So I can write now y equals negative 2/3 x minus 1. And this will be the equation in slope-intercept form as well. And once again, if you wanted to, you could have just distributed the negative 2/3, but I wanted to show you the process for whichever way you feel comfortable finding this equation. If you were to distribute that through, you would end up with negative 2/3 x, which is right here. Then you would have plus 6, and then bring this over minus 7. So 6 minus 7 is your negative 1. Okay, so there's our second example. We wrote the equation of a line parallel to this, but passed through this point. In this third example, we're going to write the equation of a line that's parallel to this line that's given to us, and this is given to us in point-slope form, and it's going to pass through the point K, which is negative 8, 4. So in order to be parallel, you know we have to have the same slopes, so our slope is going to be, and it looks like this 5/4 right there. Okay, and that's all we need from that initial equation is just the slope, because if they're parallel, just need to grab the slope because they have the same slope. And now we have this point, negative 8, 4. So, of course, our x is negative 8 and our y is 4. Let's go ahead and write the equation first in point-slope form. So y minus the y-coordinate equals m times x minus the x-coordinate. So it'll be y minus, looks like 4, equals our slope of 5/4, and then x minus the negative 8. So the minus and negative, swoosh, swoosh. So my equation here will look like this with the x plus 8. So here's the equation of the line in point-slope form that's parallel to this line, but this line passes through our new point, negative 8, 4. Once again, let's go ahead and do it in slope-intercept form as well, and I'll walk through this process, and then I'll convert this equation to slope-intercept, and we'll make sure they're the same. So our y-coordinate is 4 here, equals our slope, which is 5/4. Our x is negative 8. I'll go ahead and write that over 1 since I'm multiplying, and then plus b. So the b, which is our y-intercept, that's what we're solving for. So it looks like I can do a little bit of simplification here. So 4 equals negative 10 plus b. So when I add 10 to both sides to get that b by itself, looks like I'll have 14. Okay, so this then will be y equals 5/4 x plus 14. And that's the equation of the line parallel. But this one's in slope-intercept form. And again, we can transition from point slope to slope-intercept by distributing and then adding 4. So let's go ahead and see. So 5/4 x, that's what we have for a slope. 5/4 of 8 is 10, and when I add 4, I get 14. So yeah, we see that they're the same equations. In this fourth example, we're going to work with this horizontal line, y equals 5. So we want a new line that's parallel to this horizontal line, but passes through -12, 7. Well, this one's a little bit different from the other lines because this one is indeed horizontal. And all horizontal lines have equations y equals the y-intercept, or y equals b, or y equals the y value. It kind of just depends on how you want to look at it, because horizontal lines go through all kinds of x values since they're parallel to the x-axis, but it only has this one y value. So whichever y value you're talking about, they're all the same anyway. Okay, so y equals the y value. So the equation will be y equals, and it looks like the y coordinate of our point L is 7, so our equation is y equals 7. And y equals 7 is another horizontal line, and it's parallel to y equals 5, but it passes through point L. In this final example, we want to know the equation of a line that's parallel to x equals -3, which is a vertical line, except it's going to pass through this point L, -12, 7. So all vertical lines will go up and down, and they'll have the same x value, but they'll have all these different y values since it's parallel to the y-axis. So x will be x equals, and it's just equaling whatever that x coordinate is. So x equals -12. So x equals -12 is the equation of the vertical line that's parallel to x equals -3, but passes through point L, -12, 7.